It begins in a place almost impossibly small, an interface of cells, fluid, and soft tissue no bigger than a grain of sand. For days, the early embryo has been traveling in quiet motion, dividing and reshaping as it drifts through the fallopian tube, carried by microscopic currents. It is a cluster of possibility, guided only by chemistry and timing. And now, it reaches the one landscape where everything changes: the receptive lining of the uterus. Most people imagine pregnancy beginning with a missed period or a positive test. But the real beginning is far earlier and far more dramatic. Implantation is not a gentle landing. It is an orchestrated encounter between two biological worlds, each with its own defenses, rhythms, and intelligence. Because the truth is, the embryo doesn't simply attach. It negotiates, communicates, and transforms the tissue it touches. This tiny blastocyst must achieve what seems impossible: fuse with a structure built to protect itself, avoid an immune system designed to eliminate anything foreign, and initiate the construction of an entirely new organ, the placenta, in a matter of days. It must signal without alarming, invade without injuring, embed without disrupting the fragile balance of the uterine environment. Inside the endometrium, cells shift their identity. Blood vessels soften and reorganize. The tissue turns from a monthly cycle of building and shedding into a stable, nourishing ecosystem. All of it happens before any outward sign of pregnancy, before the embryo even resembles a recognizable shape. Implantation isn't just a beginning, it is a biological handshake, a microscopic moment where potential becomes reality, and two systems merge into one continuous story. Let's go inside. To understand implantation, we need to follow the embryo from its quiet journey through the fallopian tube into the moment it encounters the uterine lining, a landscape that has been preparing itself with remarkable precision. By the time the blastocyst arrives, both it and the endometrium have been shaped by days of hormonal signaling, mechanical movement, and cellular anticipation. What looks simple on the surface is, at the microscopic level, a choreography involving thousands of molecules, each contributing to the first true connection of pregnancy. Around day 5, the embryo reaches the blastocyst stage, a fluid-filled sphere composed of two key populations. Deep inside is the inner cell mass, the cluster that will one day shape every tissue, organ, and system of the fetus. Surrounding it is the trophoblast, a layer of specialized cells already destined for a different fate, constructing the placenta and mediating communication with the mother. These cells operate as the embryo's interface with the outside world. The blastocyst is still enclosed within the zona pellucida, a protective shell designed to prevent premature attachment. But as it enters the uterus, chemical signals trigger a process called hatching. Enzymes released by both the embryo and the endometrium dissolve the zona, freeing the blastocyst so it can interact directly with the uterine lining. Without hatching, implantation would be impossible. Meanwhile, the endometrium has been preparing under the influence of rising progesterone. Glands coil and thicken. Blood vessels dilate. The epithelial cells develop tiny microprojections, pinopodes, that help capture the blastocyst. This brief phase of receptivity, known as the implantation window, is limited to just a few days each cycle. Outside of this window, the uterus is inhospitable. Inside it, the tissue becomes one of the most welcoming environments in the body. When the blastocyst makes contact, it first enters a stage called apposition. This is not a firm attachment. It is a gentle alignment, guided by chemical gradients and subtle adhesion molecules that act like molecular Velcro. Over hours, the connection strengthens into adhesion, as trophoblast cells begin to anchor the blastocyst to the endometrial surface. This is the moment when the transformation truly begins. The trophoblast rapidly differentiates into two layers: the cytotrophoblast, which remains as individual cells capable of controlled proliferation, and the syncytiotrophoblast, a multinucleated mass that extends outward. This syncytial layer is one of the most unique tissues in the human body. It has no cell boundaries, no distinct edges. Instead, it behaves like a living, expanding interface, capable of both invasion and protection. At this stage, biology engages in a delicate balancing act. The syncytiotrophoblast must penetrate the uterine lining, but too deeply could cause damage. It secretes enzymes that remodel tissue without destroying it, allowing the embryo to sink into the endometrium layer by layer. This process is not forceful. It is controlled, precise, guided by molecular signals between embryo and uterus. The endometrium, far from resisting, participates actively by loosening its matrix and altering its immune environment. The immune system's response is one of the most extraordinary aspects of implantation. The embryo carries paternal genes, making it partly foreign. Under ordinary circumstances, the mother's immune cells, particularly uterine natural killer (UNK) cells and macrophages, would mount a defense. But the trophoblast produces regulatory molecules that create a zone of localized tolerance. Rather than attacking, immune cells shift into supportive roles, facilitating tissue remodeling and vascular development. This immunological negotiation is essential. Without it, implantation would fail before it begins. As the syncytiotrophoblast spreads, it creates tiny cavities known as lacunae. These fill with maternal blood and secretions from uterine glands, providing the embryo with nutrients during the earliest days. This form of nourishment, called histotrophic nutrition, sustains the embryo until a functional placenta can take over. Simultaneously, the trophoblast begins remodeling the mother's spiral arteries, transforming them from narrow, high-resistance vessels into wide, low-pressure channels capable of delivering large volumes of blood. This remodeling is the foundation for placental circulation. If this step is incomplete, complications like preeclampsia can emerge later in pregnancy. Even early here, the uterus and trophoblast are working together to create a stable, long-term environment. By day 10 to 12, the blastocyst is completely embedded. A protective layer forms over the implantation site, sealing it within the endometrium. The embryo is no longer drifting, no longer exposed. It is anchored, supplied, and integrated into the maternal physiology. What began as a simple attachment has become an exquisite biological partnership, one that will give rise to an entirely new organ and support 9 months of continuous growth. Implantation is a story that unfolds in whispers. Tiny signals, microscopic movements, and molecular decisions that quietly reshape the future. Long before the embryo forms organs or a beating heart, it establishes something far more foundational: connection. In a landscape only a few millimeters thick, the endometrium receives, interprets, and responds to the presence of new life with an intelligence that feels almost intuitive. What makes implantation so extraordinary is the dual transformation it triggers. The blastocyst, once a drifting sphere, becomes anchored and nourished, and the uterus, once focused on cyclical renewal, shifts into sustained support and protection. Two biological identities meet, and both change because of the other. At the cellular level, the process is remarkably deliberate. Trophoblast cells merge into the syncytial trophoblast, forming a living interface that both protects and communicates. Maternal immune cells soften their vigilance, not through suppression, but through reorientation, adapting to tolerate and assist rather than attack. Blood vessels widen, glandular secretions intensify, and the tissue reorganizes itself with the quiet precision of an ecosystem finding balance. And yet, all of this unfolds without sensation, without announcement, without any outward sign. It is one of the most transformative moments of pregnancy, and it happens silently. Before a test turns positive, before the body feels any different. The embryo and uterus are not simply touching. They are forming an alliance, a biological agreement that will sustain development for months to come. Implantation reminds us that beginnings are rarely dramatic. They are often subtle, built on communication rather than force, cooperation rather than conquest. It shows how life starts not with complexity, but with connection. How a few cells, guided by chemistry and evolution, establish the foundation for everything that follows. This first attachment, this microscopic handshake, becomes the cornerstone of pregnancy. From it grows the placenta, the fetus, the entire arc of development. It is the quiet, opening chapter of a much larger story. A story written in the language of cells, tissues, and signals that shape the next generation before it ever takes its first breath.